Welcome to the Collections Overview. After completing this lesson, you should be able to understand the structure of the Scala collections hierarchy, describe how to apply functions to data in collections, outline the basics of structural sharing, and illustrate the performance characteristics of data in different data structures. The Scala collections hierarchy represents a structure of collections that can contain data in different ways. At the top is the idea of something that can be traversed or walked. Next in the hierarchy is a specialization of that behavior that represents iteration, the idea that it could be walked a single time, that you could say, is there a next value? Is there a next value? Is there a next value? And then beyond iterable, we have specializations of a sequence, a set, and a map. The sequence breaks down a little bit further. You have the idea of a linear sequential, which is something that has to be walked one by one to find the elements that you want, such as a linked list, or an index sequential, which gives you the ability to directly access a value inside of the sequence. Scala's collections have higher order functions because Scala is a functional programming language. Instead of walking a collection and performing a transformation and putting some data into a new collection, we instead apply a function to the values inside of a container, and a collection is merely one form of such a container. There are many higher order functions available to you across the collections library, which we will discuss in a later session. Here's an example of a higher order function just so that you have an idea of what I'm talking about. If we open the REPL, and we create a collection of numbers from 1 to 10, we can then map over this data, applying a function where we say for every number, which we are just calling n, we are going to add 1 to it. And the result of that is a new collection with the values inside of it from 2 to 11. When you have data inside of an immutable collection in Scala, it is an aggregation of references to individual values in the Java heap. So, for example, on the earlier slide when we were looking at data of 1 to 10 inside of a list, we had references to individual integer instances of the integer class. They could be scattered around the heap. And when we use immutable collections of immutable values, those references can be shared between collection instances. Here is an example of structural sharing. We have a list of numbers, 1, 2, 3, 4, and 5. Each one of those numbers inside of the list is not actually the number itself, but a reference to a value on the heap that is 1. It just looks like the value inside of the list, but really the list is holding on to references that point to those numbers. If we append 6 to the end of this list, we then have a new list with 1, 2, 3, 4, 5, and 6. The only thing that's really been added is a new collection of references pointing to the 1, pointing to the same 2, pointing to the same 3, with a new 6. And then if we take that res1 and we prepend 0 in front of it, we again reuse the 1, the 2, the 3, the 4, the 5, and 6 from res1 to create a new list of references with a new reference to the 0. And don't worry about these prepend and append operators that you see inside of this. I'll be explaining them in a later session. Scala's collections have well-defined performance characteristics. And if you go to this web page that is shown, or if you do a web search for Scala collections performance characteristics, you'll find a page that has every collection in the collections library and its performance using various operations, such as accessing the head of a list, which is the first value, the tail of the list, which is everything after the first value, or updating the list or prepending the list. These operations have different performance characteristics that are based on whether they are constant time or they are linear, such as I have to walk to the end of the list to perform this work, or effectively constant time, or amortized constant time. Having completed this lesson, you should be able to understand the structure of Scala collections hierarchy, describe how to apply functions to data in collections, and outline the basics of structural sharing. You should also be able to illustrate the performance characteristics of different data structures.